Alright, time for another draft science. Whoops, draft physics here. Yes, it's draft science on YouTube, draftphysics.com as a website, and then debatephysics.com as a website. And unfortunately, there really isn't any nice, coherent back and forth debate, but, maybe someday. Uh, someday. Over the rainbow, blah, 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 whatever. All right, so wave particle duality is this video subject, and I should, oops, did I hit that button? Okay, there. Now it's up there. So I did write another page of crap. I mean, it's just really notes, so it's not nearly good enough for much use. Needs to be itemized, compiled, blah blah blah. Go through all this crap to make all the points there is to make about all the things that are stated by conventional physics that flatly aren't true versus all the ones that are just misinterpretations of things, and they can be stated in much clearer and much more accurately than they state what the phenomenon does and what are reasonable statements to make about it. Alright, so I'll go through the double slit thing again, and I will, again, it's not going to be, ordered. It's not going to be as constructive as it should be yet. And that's unfortunate because I just, anyway, it's just, so Einstein wrote 3 pretty short papers, okay, in 1905, and it is kind of funny that I'm heading towards 3 major, the big subjects, and you might end up in a similar place, but it is just so, it's just an irony about it is that Einstein was wrong in a couple of those papers. Now, Brownian motion, good paper. But the relativity crap, yes, obviously nonsense. And the photon one is darn close. So his argument in defense of a particle theory was good, but the paper is so brief and so incomplete that he doesn't draw you a photon. So there's no way of really understanding. All right, so the first step in this process is just acknowledging that photons could be very different than what you imagine them to be. So a photon is not an object, okay? A photon, this is not a photon, okay? You don't put a P on something and say they're a photon. It really isn't. It's an event. Photons are a process, and they're made of things, okay? Elements, all right, that have the frequency. The frequency isn't the size of the photon, or some kind of notion like that. The frequency, the wavelength, is a distance, a period between events. So it's an object that, it could be 2, could be 3, could be 4. Well, I think it has a minimum of 3, frankly. These are what this part is what Einstein, was innovated in the sense of stating he invented these words, okay, the use of them anyway, photon and quanta. And what he called these were light quanta. So you could argue that he did state or have some view that might have been similar. But as far as I can see, there was nothing in his paper that said, okay, the photon itself is made out of light quanta that come at a frequency. So, he just quantized the energy of elements of a photon without caring whether there was 10 photons or 100 photons, right? That's really the difference here, right? I could say there's a 100 elements, or I could say there was 33 photons. And it really wouldn't matter because it's really about the energy that's conveyed by whatever hits the surface. So anyway, so the idea of a wavelength would just be a period between events. Okay, so this wavelength or frequency is, these are all concepts you can understand that there's more than one word to describe stuff that happens at a sequence. Now, their understanding of the photoelectric effect is that they have some idea that you know, an electron is at the bottom of a well, let's say, and you need a certain amount of energy to pop it out of the well, and that's why blue light works and red light doesn't. It's because red light doesn't bounce the photon out of the well high enough. You know, it just bounces it this high, it doesn't get out of the well. Something like that, some kind of argument like that. Now that argument is very similar, but it just isn't, to an argument where you would just say it's a tipping point. That, you know, if you want to knock something over with energy, that you have to put the energy in a sequence that matches how the object will move. So if you did have an object and you hit it and it tipped a little bit, but it was going to go back to its original position, you'd understand that you either have to hit it with more energy before it starts moving back with any velocity, or you know, you wait for it to swing and then you hit it again and add energy. But you have to add the energy while the object's moving in the direction you want to add energy in, okay? Or you have to add the energy while it's still, you know, displaced from its original condition, so you can add the extra energy and get more and more motion out of it. So it's just, if you want to tip something over with pieces of energy that aren't individually strong enough to knock it over, and you have to add the energy when the object's moving in the direction you wish to add energy. And if you add the energy when it's going in the opposite direction, you will fail to tip it over. Okay, so I'd argue that this is closer to the electron condition, okay, is that the electron is motivated, okay, by all of these light quanta, add energy, and the idea is you have to add the energy while the electrons are jiggling in the right direction. Okay, so the electrons are in a condition where they're pressurized with each other, it's all balanced, and if you hit one electron, you sort of hit all of them. So you could put energy into this electron, cause this electron to move this way, and obviously if you could add energy again to a system while the electron pressure is in the right direction, you can increase that pressure. So you could imagine if this was in the second atom, and you had now gotten this energy is now pushing this electron in this direction, and then you add energy here, then this electron gets pushed with more velocity. So you're just trying to keep increasing the velocity of the electron. And you can only do it with ultraviolet light because it has this quicker frequency, the period. Okay, the period is fast, so it means that the electrons don't have time to get back to where they were, and their motion is still continuing in a direction, and so you're adding the energy. And if you use red light, you won't add the energy because the objects, the electrons, will start spreading their energy to all the other electrons, and they'll start losing energy. So you have to hit the electron behind the electron while it's still moving with the pressure you already added. And that's why high frequency light works, is because it keeps hitting something before it can go back. Okay, tips it. And red light doesn't. Okay, so that's simple. All right, so that's the photoelectric effect. And you sort of have to go here to appreciate how close Einstein was to a reasonable explanation of the double slit experiment and the idea of entanglement and ultimately the idea of interference. Okay, so what was already known, what's always been known, is they just don't care to accurately represent what we're talking about. So you can have a single opening, and the idea is they're comparing that to a water wave. So let's just understand that a water wave would just be, I drop a rock in a puddle, and all I'm going to get is concentric rings. Okay, there will be no interference if I drop a single rock in a puddle. No interference. Okay, if I have a single opening in water, okay, I have a wave center. Okay, I have a wave, I don't have any interference. And obviously in the single slit in light, you can create you can create dozens of fringe bars. Okay, so it's not like it's a, there's really just no comparison. There's no equality or, oh, it looks just like. It doesn't look just like. All right, and the real key thing to recognize is that there's no idea. Okay, they draw it in all kinds of silly ways. They say things like Huygens, and they pretend that, let's say this was the slit, that somehow, all right, the slit creates two waves here split in the middle, and there's two waves coming out of the single slit. Well, that's not their math, because the wave centers would be here, and they don't do that in the math. Okay, this is the math that works. Okay, these 2 points, these two positions in space, this distance is the distance that works mathematically in terms of predicting these fringes. So it's clear that the wave centers, if there was going to be waves, would have to be right here on the surface. So right there they get a big fail in terms of honesty or integrity in describing the experiment accurately at all. So, and this would give the indication, frankly, if this was this wouldn't be so mysterious if you just said, okay, I'm going to create 2 points in space, and what I'm going to do is have light come from those 2 points. Clearly you could understand, then it becomes quite understandable that those 2 surfaces are independent surfaces. If they just produced scatter, there would certainly be places where you'd say, if this was at a frequency and this was at a frequency, that is, they both had a period, okay, of light coming, you could say, yes, there's places where both of them hit in phase and places where both light sources produce no light. So if you use blue light and red light, I don't know if that's a good example. You still have to have it turning on and off. So you're blinking on and off, a red light source and a blue light source. There would be places where it would be purple, there'd be places where it'd be blue, and places where it'd be red. All right. Because of the matching and mismatching of when light can hit the surface, because of the time delay in the transmission time. The only problem with that is you have to put the 2 light sources pretty far apart, because the rate at which you're going to blink the light isn't going to be anywhere close to the frequency of light, which is very high. All right. Okay, so there's a lot of whether it's overtly intentional deception. The fact is it just confuses people, because they don't accurately describe the experiment, and they claim that somehow single slits produce just blobs, and no, it's just not true. And so all you're really doing in the double slit is you're combining 2 single slit experiments. So this is another way to illustrate it. You're just saying, okay, I'm going to slide these 2 patterns into each other, and I'm going to get a new pattern. And the distinctive feature is going to be what? Is it just 2 single slit patterns going to be on top of each other? Well, no, they're not. I'm going to leave a distance here, okay, between the 2 single slits. All right, and so what am I going to create? Well, I'm going to create new distances for the point sources. So you can understand, if the surfaces were point sources, you can understand I have new wave centers. I have a wave center here and here. These 2 outside ones are going to be very far apart. These 2 will be closer to each other, and then I'll have this third distance here. So I'll have a distance here between 2 points. I'll have distance here between 2 points, and I'll have this big distance here between 2 points. And all of those are going to obey these surface rules, these point source rules. Like if these were lamps or headlights, that there's rules about how the light can travel, as it travels distance. If the light has a frequency, that frequency is a wavelength, a wavelength, a wavelength, a wavelength, a wavelength. This light's going to have a wavelength, a wavelength, a wavelength. And this is the full wavelength argument, that these sources have to be their distance is going to dictate whether they will be in phase. That means their frequencies will be full wavelength, or they'll be out of phase, something less than a full wavelength. And the idea is if they're closer to full wavelength, and further from complete opposite wavelength, that's on and off. Okay, and you see the graduation in the pattern. The pattern sort of gets, there's some hardness to it, but I mean, there's basically, the idea is it goes, you have a place where there's no, they're completely out of phase, and there's a place where they're completely in phase, and then you have this gradual transition between those 2 points. So anyway, so the final result in the double slit, right, is that you have this complex pattern. Drawn it so many times, where you have elements, and let's just, it's always an odd number here in the middle, and then you have a divisible as the secondary pattern. So basically, if you were to say these were nodes, this 3 and this 3 were a node, that you could sort of understand that those two have overlapped here in the middle. So they're all this 3 size. They all come in 3 unit, except here you've overlapped that pattern. But that's so all I'm really arguing is that you have a 3 and a 3, and the 3 and the 3 have overlapped, okay, and so it ends up being a 5. But this is the pattern you get. Okay, so there's 2 patterns. There's this, and then there's the center double maxima, and then this. And so this is duplicating the single slit. The single slit does this double maxima thing. Okay, so the big pattern, the envelope pattern, is producing a single slit type pattern, and then the little bars, okay, with the missing bits here, okay, and they keep missing as you go on, is what's traditionally understood to be what you could call, that's the signature of the double slit. And all you're really done, okay, if you just analyze it both mathematically and geometrically, you can completely understand why the pattern has been produced in that fashion by just understanding this simple rule about distances. So this distance, okay, the widest distance will tell you how big these little bars are. Right, so the little bars are going to be dictated by the widest distance, because you could sort of understand the widest distance means there's more places where there's a full wavelength of difference, because you have a greater base. The larger the base, the more places you could go to where these 2 lines will be a full wavelength of difference. And the closer they are to each other, the fewer places there can be a wavelength of difference. So the little bars are being created by the widest distance, and one of these smaller distances, okay, is dictating essentially the envelope pattern. It's dictating how many are grouped before you have a break. So the envelope and you can just perfectly understand why there's 2 patterns, because there's 2 things you've changed by bringing those 2 slit patterns together. You had one number, this distance. You had one number, this distance. They could be the same number, but when you bring the 2 together, now you have 2 new numbers. You have this distance and you have this distance, and that's why you get a completely different pattern. So the geometry is that simple, and now it's just a discussion about, once you have that geometry down, it's just a discussion about point sources, frankly, and understanding that how do photons create sources that aren't, they're not full photons that go from here to here. These are pieces of a photon, essentially. They're going from these places and recreating a photon. Now I could compare this, I could use the analogy of polarizing film and explain how it doesn't destroy photons, and so clearly it just breaks photons and then can restore them. So you can have two pieces of polarizing film in opposite orientations, and you can shove a third piece in and you'll get photons back. You'll somehow fix the photons. And so it can really be understood that that's a concept, that you can actually alter the photons so you can't see them anymore, and then you could easily alter them again and restore them so you can see them again. And the same concept is active here in that you're taking photons, the pieces, the elements of a photons, right? You're just distorting them, and the odds are 50-50. You either put them back in phase or you don't. So that's all there is to it. There isn't much else, and so you have a 50-50 chance at any one location that you have either a photon that is functional or one that you broke. And by understanding that it's just bits, you can understand all that. So the key point here is their math is completely accurate in the sense that if you take it seriously, okay, don't let them, when they draw this diagram, okay, this is not mathematically what they do. So when they draw this diagram with the waves here, and the waves come out here and they interfere with each other, when they do that, they're that's just lying, okay, because mathematically the wave center would have to be here, okay, and they don't use that number mathematically. They never use this distance mathematically because it's mathematically a useless distance. So they either use this distance or they use the distance of the slits. And the real trick is they often play this game where they say, the slits have to be infinitesimally small. Well, obviously what happens when you make the slits infinitesimally small, you essentially destroy any hope that these two surfaces here could create an interference pattern. There won't be any pattern. So if I make a single slit really small, there's no interference pattern because there's no wavelength of difference between 2 points ever. Nowhere on this arc can I make a wavelength of difference. So there can't be any fringe pattern because I have put the point sources so close to each other that there's not a wavelength of difference in the base. Then there can't be a wavelength of difference at any point in space. So I've essentially just turned a 4-point source, okay, a 4-source experiment into a 2-source experiment. So they have technically what is a double slit, but technically it's really just a single slit experiment because they've taken 4 sources and just turned it into 2 sources by putting 2 of the sources so close together that they're essentially one source. So if I put 2 headlights right next to each other, you're not going to see it as 2 headlights anymore. All right. So it's that simple, the math chicanery and games played. So they end up predicting a pattern that isn't really a double slit pattern, and it just converts it into a single slit. And again, the geometry is very simple, and they really are using the surfaces, the distances between the surfaces. So you could argue the single slit is the 2-surface experiment or the 2-source experiment because you're creating 2 sources. And the double slit is the 4-surface or 4-source experiment. It wouldn't be the 2-wave experiment, okay? 2 waves won't work. 2 waves won't explain the double pattern. It won't explain the envelope pattern and the pattern inside there, okay? 2 waves can't create the pattern. 4 sources can create the pattern, quite obviously. All right, now I guess I will go into the simple mechanical explanation. There's so many little details. I mean, the fact that this is the experiments they've never done, just to verify. And in a sense, they have done them, because when they use a variable single slit, what you'll observe is the pattern disappears as you make the slit wider and wider. So you go from a narrow slit with a very large pattern, okay? The nodes are very big. And as you go a little wider, okay, then you'll start getting, you'll have one double bar in the middle, and then you'll have lots of little bars on the sides, okay? And then you go a little wider, and the whole pattern reduces to a tiny amount of space. Now, obviously, the reason why it's reducing in space is because these bars are getting smaller and smaller. But what you also notice is there's no light here. All of this space is, there's nothing happening. Okay, indicating that this pattern is not waves, because water waves would be just as powerful going this way, as that way. It's all the same intensity. So there should be little dots going all the way across here still. But they've been annihilated. Because what you really have to understand is the pattern, okay, is this is an equidistance. Okay? You want an equidistance that you're measuring from. So it really should be understood that the experiment should be done on a curved surface, because you want this, even in the math, this L distance is always the same. So obviously when you're comparing a point, it should have the same distance. All right. And obviously it just illustrates it better. And what the pattern is actually doing, okay, is that it starts off little, okay, the nodes, and they get bigger and bigger and bigger and bigger. And that could be noticed. All right, and so there's always a standard number of them. You're really just saying, okay, what's the length here to here? What's the length here to from these 2 points? And you're just saying in phase, out of phase. And it's a mathematical reality. And so obviously here we'll call this 0 degrees. Here's your path length. Here's your difference that's the maximum difference right there, right? You can just take the 2 and put them on top of each other, and this is your total number of places where you can have a wavelength of difference. So you just multiply, you just divide the wavelength into this distance, and it'll tell you. And what it's also going to tell you is that you have, let's say you have 15.5. So you have 15 wavelengths fit in here with a remainder of 0.5. Well, you know that 0.5 is right here. So you know this isn't off right here. Has to be. They're out of phase here. And this is rigid. There's no way to change this proportionality going up this slope. So you know that in this middle part here, this also has to be an off. Okay. So that's the funny part. Is that, you know, they'll say things like Professor Lewin say it's non-negotiable that the light from this source and the light from this source have to be right here in the center. It has to be an on because it's the same path length. Well, that path length is happening inside less than a millimeter. This pattern is a foot across. You're not going to see the millimeter in the foot across pattern. Okay, so that all happens inside 1 millimeter. You're not going to see any of that on the wall. Okay, so that part, the fact that that's equal doesn't matter, because the real pattern is being created on this arc and this arc. All right, and these two are 2 separate sources, 2 separate patterns, and you're pushing them into each other essentially. So there is a little tiny fraction of the light ends up going in the same direction. You could sort of understand that. I mean the opposite directions. And that all the rest of the pattern will be created by light going this way and this way, or this way and then this way. So all of this is created by the 2 sources going in the same direction. All of the stuff on this side is 2 sources going in the same direction, and only the tiny stuff inside of 1 millimeter is going in opposite directions. So you can sort of get how their analysis is kind of a mess in terms of it doesn't accurately represent what would physically happen if I could enlarge this, or I could put it, you know, on a scale where you could actually see this happening. The fact is that it's a finite pattern. Once you know this number, okay, once you know what the total distances and how many wavelengths fit inside of it. You already know exactly how many of these nodes are possible. Now the experiment they've never done, okay, as far as I could do any research to see, is they've never taken photographic film or electronic devices or anything to ever measure that field. So they'll talk about a double slit experiment. And what they've never done is, they'll measure light here, but they've never tested here or here. So they've never taken photographic film, just put it over here. See if any of these photons are remade over here. See if you actually can reconstruct photons in these locations, if photons get here. If your wave interference that's supposed to be just as intense here as it is here. I mean, waves sort of demand that the intensity really is the same across the entire wavefront. So your wave creates the same strength here, same strength here, same strength here, theoretically. And so this pattern should be just as bright as this pattern. And the real point is that I'd say there's no pattern here because no photon even goes. The scatter is limited. So the scatter is really only capable of scattering, this much. It can't scatter in all these directions. So like Compton scattering or some other kind of scattering, very rare that you're ever going to get a perpendicular scatter. Okay, you're going to get a scatter in the mean. It's going to retain the mean direction, and there are certain probabilities about how much off of that it can be, and I will explain why that would exist as a limitation in the experiment. Used up the whole paper. All right, anyway, so I'll take a pause and we'll switch to an explanation of why it's really kind of easy to explain what's going on if you understand, if you can appreciate Einstein's idea of light quanta, or the idea that there are this quanta, this small stuff that makes a photon. Okay, that a photon isn't a solid object, that a photon is more sensibly understood as an event. It's a frequency hitting a surface. That's a photon. That's why frequency is really important to whether there is a photon or what a photon is. How could you know the frequency? You could theoretically argue, how can you know the frequency if there isn't more than one object? All right. How could it have a frequency or a wavelength? And the idea that a surface could possibly measure, let's say we know radio waves can be 10 miles long. Their wavelength can be 10 miles. So obviously the same place on a surface couldn't possibly receive a 10-mile signal, but everything's moving all over the place. So, there'd be no way that a single point, a single small space on a surface could incorporate a 10-mile object because it would all move away from the object's motion. So, there's so many good, reasonable arguments why you can understand a photon can't be an object. It has to be an event. All right, back. I probably didn't fix the date on this video, so whatever. It's always little details. I'm just not healthy enough and too old, too tired for this. But anyway, I wish I was 25. Anyway, I wish. Silly thing to do. Anyway, all right, so the whole point of, I brought up Einstein. Like I said, I can't be clear exactly on what Einstein's arguing, but we can know about this whole Brownian motion thing. We already know what atoms look like, with the electrons on the outside. And so obviously a surface, you could argue that any surface is going to be an electron it's going to be electrons first. That's the first way you're going to see a surface is the electrons on it. And you could also argue that it's going to be pretty clear that the electrons, even if you just thought of it as heat and the atoms moving, that the electrons are going to be doing something sort of like going into the surface and coming out of the surface. Those are going to be the two motions. They're going to be perpendicular to the surface, and the electron energy, the pressure, just like you bouncing on the Earth, you could argue that you're bouncing on the Earth. The Earth pushes, gravity pushes you in, the Earth pushes you back. And you can feel that happening, okay, constantly. So you're essentially jittering on the surface of the Earth. The electrons are jittering on the surface of a substance. So the surfaces of the slits are covered in electrons doing this. So you're going to understand you have this motion going back and forth. You're going to send your photons through. So your light quanta. All right. So let's say this is a photon. These four elements at these precise distances from each other. Okay. That's a photon. I'm going to send it into this slit. A certain number of the photons are going to go right through. They're not going to be bothered. That's why the central maxima is very, very bright in the single slit. Is because, a whole bunch of the photons are going straight through and just hitting like a laser beam. They're just hitting because you've got pretty coherent light, right? Part of the whole point is to have this collated, what's the right word? Cumulated, okay, light that's been made to be quite parallel. So it's all traveling very straight. That's the whole point of doing the single slit in the old days. They did a single slit first, then the double slit later, to force the light to be very straight, so to speak. So anyway, so a whole bunch of it goes straight to the middle, just like a laser beam. All right. The fringe light, all the fringe light will be surface light. That's the key, right? So all of it, all the light going over here, all the light creating any kind of bars is all light, all photons that had to hit one of those surfaces, go very close to the surface. And all you're really arguing, all I'm arguing is it's kind of a simple explanation. So let's just say, let's make the electron red. Try to enhance the viewability here. All right, so this is your electron. It's moving in and out of the surface. Let's say you hit it with momentum from one of these quanta. So one element of this photon, okay, then they're running a little off parallel, they're not right behind each other. I mean, I didn't want to technically get into this, but they're polarized, so it means they're in different places in space, but they're moving in exactly parallel. Whoa, that's not a good thing. Whatever I dropped into my computer, that's not a healthy thing to do. Anyway, it's one of those days. Anyway, okay, so back to this. All right, so the photon is coming in. It's going to some of these elements are going to hit electrons and some aren't. So what happens when it hits? So the electron has momentum going in these directions. All right, it's either going out or it's going in. The photon has its momentum in this direction, and all you're really going to argue is yes, what's going to happen? Well, if it's going out, then the new momentum of the electron will be something like that. And if it's going in, then the new momentum of the electron will be something like that. And that is creating the scatter at the surface. So the scatter at the surface is being created, okay, by the hitting electrons that are moving. And the fact is, you could hit 10 electrons, you could hit 1 electron. And the more electrons you hit, the more you can be bent. But it's a certain limited probability. You can't hit 1,000 electrons, let's say. It'd be impossible to hit 1,000 electrons in the thinness of the slit. So there's no possibility of ever having this product. You can never scatter that much because it's a limited amount of momentum in the electron, and there's a limited amount of momentum in the quanta of light, the light quanta, to use Einstein's language. All right, so you can understand why there's scatter at the surfaces, right? The surfaces are bending light. So they say particles don't bend. Well, the fact is particles can bend. You can scatter particles. Okay, you can create a mechanism where it forces the particles to fly off at an angle. Okay, you distort their momentum. And yes, I'm saying the electron is what actually moves. The electron is what's actually going to create the new quanta, but I don't want to go into all those explanations. I'm just saying if you understand the momentum equation, you have a momentum this way, you're going to combine it with a momentum this way, obviously you're going to get a momentum somewhere at some other angle. And it's Compton scattering essentially, so we don't need to go through a whole bunch of argument about how physics has never observed this, because of course it has observed it. Okay. And so it's a routine fact that atoms scatter photons, and that the part that's scattering them obviously is the electron. So with that simple explanation, you can just understand that the light quanta will be scattered by the surfaces. The scatter, it's just back to the geometric argument, okay? Nothing's changed in the math. Okay, you're just taking this distance and you're saying these are two sources, and then you're just doing your geometric math to say which length of line is a wavelength of difference. It's exactly the same rules, and all you're really saying is that if I send this one off in another direction, and then some other photon got broken in some other direction, I'm throwing a bunch of pieces, and all of the pieces are on this plane, right? So, I mean, the electrons are bouncing in and out this way. They're not bouncing in and out this way and all kinds of other ways. This way, in and out, okay? And so that's why the fringe pattern is on one plane, is because the momentum is in one plane. All right, and you're not changing that at all. All right, so the scatter is only in this direction. So it goes through the slits, and the scatter is only in this direction and that direction. It's not this way and that way. All right, because there's no electron moving this way and that way. There's just electrons moving this way and that way. All right. It provides a perfect explanation for a physical mechanism to create the fringe pattern. The fringe pattern is just a surface phenomenon. The surfaces cause it. The surfaces is where the mechanism exists to cause interference. Okay, so the interference is with electrons. It's not with photons. Aren't interacting with photons. Photons are interacting with electrons. The photon is being altered. So a photon that had a consistent phase, all right, obviously if it's missing an element, okay, so it's missing a piece. Now when it arrives at a surface, it's missing a piece here, okay, and the fact is that that piece can be provided from the other surface. The other surface can put that piece there, and it's just a matter of being in phase or out of phase. Those will be the two choices based on the distance. Okay, is that it'll either be the correct distance to be almost in phase or almost out of phase, and it'll only show up that way. It's either going to be you remade the photon, or it's too far out of phase. That is too far. It's the wrong frequency. Therefore, no photon. But anything in this range, photon. So if it's anywhere close to this, in this little bit of flexibility the photon provides, you'll see the photon. If it's not outside that range, it broke the frequency, no photon. Now, just for clarity, but I mean these really are kind of deep subjects. You can go into a lot of stuff. I'll do a little bit of explanation of why photons are a thing in the first place, how they're created. So let's just say you have a surface, and we recognize this electron rule. And now we recognize that the atoms themselves, back here, okay, are all connected to each other. All right, they're all have an equal electron pressure. Any pushing on one electron essentially pushes on them all. So the idea is, as a photon hits, okay, the light quanta, okay, come into a surface, and what they do is they push on these electrons, and they push in the in direction. But what happens inside the surface? Well, when it pushes in, you can understand that if this was the nucleus of the atom, okay, and these are the electrons, you can understand that it's pretty easy for this pressure in to push these electrons out. That's your perpendicular or tangential property of electromagnetic effect. This is how you create electricity. Is you push one way on an electron, the pressure, well, obviously in electricity, in a wire, you're pushing in the same direction as the force is going to go. But I'm just explaining induction type electricity. This is how it's created. You push a force, you hit the surface of something with a force, and you're creating energy perpendicular. Okay. In the sense that you're creating motion in this electron. And you could just understand that now if I hit with another piece, so I have an electron that is moving this way, and then I hit another atom behind it and cause even more pressure to push on that electron and make it go a little faster. And then I hit it a third time and I make it go a little faster. And you can understand that's the photoelectric effect. You get it going fast enough, you've caused electricity. You get it going even faster, okay, and what you're going to end up doing is ejecting electrons. So if you get enough speed, you'll push the electron right out of the substance. If you get a certain amount of speed, a level of speed a little less than that, you'll have electricity moving through the conductor. And, so it's all quite consistent. It all fits together. This will give you an explanation of the function of magnetism and electricity, the connection between them, and it's perfectly consistent with a model that also explains. So I'm just saying the model also explains. All right, not just the double slit experiment. It explains the creation of photons in the sense that we detect photons by detecting the event of electricity. We don't detect a photon, we detect electricity. Frankly, your eyes are doing it right now. They're converting the photons into electricity. Okay? You're seeing electricity. You're not seeing photons. You're not seeing light quanta. Okay? You're seeing what they can produce. And the real truth is that something like gravity is light quanta a long way from producing electricity. That is, it doesn't have enough signal in it. It doesn't have enough frequency, okay, and enough density of stuff moving at that frequency to be detectable, to create electricity so we can know it's there. Okay. You can't make electricity with gravity. But it's the same mechanism. So you have the stuff in the universe, the force moving the speed of light, the light quanta, and you have the matter bits, electrons and protons, that are pushed by the light quanta and moved. And when they move, we know what happens. We know we can approximate those effects quite easily in understanding that it's a blob of momentum. An electron moving a velocity is a blob of momentum. And if you move enough electrons, you call that, a 10-ton truck moving 50 miles an hour. That's a lot of electrons moving 50 miles an hour. Okay, it's a lot of mass. Okay, atomic mass moving. And electricity is just atomic mass moving, but it's on a different scale, and it's much more organized. That is, there's less noise in its motion. It's more like a laser beam, stuff going through the wire. All right. Do I really need to go any further? I'm probably missing some key point. I probably should just read the paper eventually. So again, I'll link to that, and that should be developed over time. I should try to, I will try to devote some time to writing, but I'm just not. I just, it just isn't. My brain just wants to say, look, physics is wrong. You're all assholes. Fuck you. You couldn't care less about the truth. Fucking get what you deserve. I mean, I just don't have any patience to attempt communication in some kind of book form where I have to say a bunch of crap unrelated to the specific little arguments I wish to make, which is your model doesn't work. It never was accurate. Okay, you don't use in the math, your two waves aren't in your own math. You're not using the math of the wave centers. There's no point in telling me about how waves interfere if you're not even going to use the center of the wave in your own math. I mean, the lies and the deceptions and the cheats, it's just terrible. The whole Huygens nonsense. Oh, come on. It's a pathetically irrational theory. An infinite number of something. When a physicist starts telling me there's an infinite number of them, well, so yeah, I just, I have a hard time being civil. I want to write a pop-up book that has a fucking hammer that comes out and nails you right in the head. Because, I shouldn't even have to make these arguments, frankly. This physics should have been done. I don't know how Einstein missed it. I don't know how I guess he just didn't draw enough pictures. But I just mean, all you have to do is start illustrating what takes place, and it becomes apparent, okay, that, the distance between the surfaces, yeah, I can't draw waves there. I mean, some physicists should have done this, right? I mean, is this that hard to do? This simple little process. Here, I have a surface. Okay. Now, I know mathematically this is the distance I'm using. This is the distance. They call it A. Okay, this is the distance I'm going to use. All right, this is the distance I'm going to put in my math. Why would I draw waves here? That's silly. Why would I draw two in the first place? Well, Huygens says so. Huygens. Fuck Huygens. All right, and then when you know that's what's really going to happen, one big wave was just going to pop out. So we know in light, I got to make two waves. Well, how can I make two waves here? How can I possibly make two waves? And you're telling me none of you could just sit there and draw this and say, oh, well, the wave would have to be here, and the other wave would have to be here. That would be the only way it would work. And why would waves start or initiate halfway over the surface? Well, I can't make that make sense. Maybe it's not waves. Maybe it's just scatter. Yeah, scatter works just fine. Yeah. And I can scatter particles. Really easy to scatter a particle. So that's why I have no patience. Alright, so anyway, I think that's enough of an initial video. So I will number these, title them, all that kind of crap as consistent and coherently as possible, and we'll see how this progresses. So there will be a third and a fourth subject. So those will be my 4 papers, or Einstein's 5 papers. Maybe I can write 5. About these elemental physics subjects, where physics got it so wrong and for no good reason got it way wrong. And the reason why they got it way wrong is because they wanted a religion. They didn't want a science. They didn't want, it's not that they didn't want the truth. They didn't want a crude, ugly truth. They wanted some kind of interesting truth. Some kind of crap like that. The fact that it is a terribly mechanical. Nobody wanted to hear it when Descartes said it. Nobody wanted to hear that the universe was set in motion and there's no role for God to play. They didn't want to hear that. Alright. So anyway, till the next time, and such, and so forth, and whatnot.